Alright guys, so this is just going to go as a quick review before you take your proficiency check in class today. So what I'd like you to do for each of these is to try the problem on your own really quick. Take about 2 or 3 minutes. If you get stuck, then you can just hit play on this video just to get that quick reminder of how to do these problems. What we're going to be looking at is just solving systems of equations by elimination, and then really any method today, just before your proficiency check so we can get that review in. So here we go. Let's take a look at this one. Go ahead and pause the video, give it a shot. All right, we're going to see right away. Remember that step one is to make sure that my x's are lined up with my x's, my y's are lined up with my y's, so on and so forth. And you'll see here that my y's are not lined up. My variables are not lined up. So we'll note that we're trying to get everything into standard form, ax plus by equals c form. I got my x's here, y's, and c's, so this one's good to go. But this one right here is not. So that's the one we're going to work on really quick. I'm going to pull that one over here to the side. That's x plus 2 equals y. So now I notice two things. My constants are on the wrong side, and so are my y's. So the way I'm going to work with that is, first off, by getting this 2 over to the other side, and the way we talked about that in class was just by subtracting 2 off both sides. That gets the 2 off of this side because I don't want it here, and it also moves it over to the other side. So y minus 2. My other issue is that the y needs to be over here on the left-hand side to get it into standard form. And the only way I can get it off the right-hand side is to subtract that y off of both sides. And that's going to give me x minus y equals a negative 2. So here we have our new equation, which is the same equation. It just looks a little different. So now I have a whole new system, though. Let's write that over here. We have my new one, which I'll just put right here, x minus y equals a negative 2. And my original equation that I had right here, 2x plus 2y equals 11. So let's take a look here. What happens if I add these? Once we have them both in standard form, step 2 is to eliminate. The problem is when I try to add these together, I get 2x plus x is 3x, and negative y plus 2y is just 1y. And I'm not going to continue here because I did not eliminate a variable. So now I need to do another step, and this is where our multiplication comes in. I'm just going to take it one way. You may have taken it another way. I see that it's probably going to be multiplying by a 2 here. I'm going to go ahead and multiply everything by 2. So this can be a negative 2 here. That's kind of the goal. So let's multiply. It gives me a new system. 2 times x is 2x. 2 times negative y is negative 2y. And 2 times negative 2 is a negative 4. My other equation stays the same. 2x plus 2y equals 11. Now the question always does come up, how did we get this 2? Again, I wanted this coefficient to be a negative 2, so it would cancel out with this positive 2. I also could have multiplied this top equation by a negative 2 to put a negative 2 out here in front of this x, so that the x's would cancel out. Either way is fine. So let's take a look at this now. If I add these together, 2x plus 2x is 4x. Negative 2y plus 2y is 0. And bring down my equal sign. Negative 4 plus 11 is 7. And here we can just solve for x by getting rid of the coefficient. And gives us x equals 7 fourths. Okay, and I'm okay with the improper fraction. You could also write it as, as a mixed number, I guess, 1 3/4, or 1.75, however you'd like. And I'm going to use that same x variable there to solve for y. And I can just use any of these two original equations. I'm going to go with the x plus 2. Let's change the color up here. X plus 2 equals y. I know the x equals 7/4, so we're going to substitute, always using those parentheses when we do so. 7/4 plus 2, well, we also know that 7/4 is 1 3/4. So 1 3/4 plus 2 is 3 3/4. So there is our last one. Remember today, when you guys submit your answers in your proficiency check, make sure you guys put it in as an ordered pair, where the x coordinate comes first, and then the y. X coordinate is 7/4. The y coordinate, as I guess if I want to leave it as an improper fraction, this would be 15/4. Or you could do any form, a decimal, mixed number will be fine. Okay, so let's back it up a little bit. Let's take a look at these two right here. Go ahead and pause the video and give these two a shot. All right, step one is to make sure they're in standard form. They're almost in standard form. We got x's, y's, constants, but this one right here is y's, x's constant. We don't have my x's lined up or my y's lined up. My equal signs are good, and my constants are good, though. So let's take a look at rearranging these. We're going to get a new system here. And we're just going to use the commutative property of addition because these two numbers are on the same side of the equal sign. So my first equation stays the same. 5x plus 2y equals 6. But here, I'm just going to change these sides. This is a positive 9x. That is a positive 2y. And then equals 22 from right here. You'll also note that when I add these don't cancel out. 5x plus 9x is 14x. 2y plus 2y is 4y. So this does not eliminate. So we need to multiply. It's still part of step 2. So let's go ahead and write my new system. And let's see what we want to cancel out. Let's just pick a variable here. Looks like my y's will be really easy to eliminate because they already have the same coefficient. Although if this were a negative 2y, or if this were a negative 2y, then we'd be good to go. So let's back up and see what we have to do to both one of the equations to get there. I'm just going to go with the top equation here and multiply it by a negative 1 so that this turns into a negative 2. So we have negative 5x minus 2y equals negative 6, and I'm just multiplying each of these by the negative 1. Second equation stays the same. 9x plus 2y equals 22. And now we can add to eliminate. Negative 5x plus 9x is 4x. Negative 2y plus 2y eliminates. Negative 6 plus 22 is 16. And then divide both sides by 4 to get x equals 4. Now we're going to take that and substitute into an original equation. I'm going to go with, let's see here, I'm going to go with the second equation here. 2y plus 9x equals 22, but I know what x is. X is equal to 4. So 2y plus 9 times 4 equals 22. 9 times 4 is 36. We're going to subtract 36 from both sides. I'm left with 2y equals 22 minus 36 is negative 14. And divide both sides by 2 to get rid of the coefficient. And then y equals negative 7. Again, ordered pair here. X first is 4. Then y comma negative 7 is the solution to this system. All right, these ones are completely weird here. These are not in the standard form. So why don't you go ahead and try to get these into standard form. Pause the video, see if you did that right. And you can pause the video again to try to finish out the rest of the problem. All right. I'm going to just rewrite these really quickly. I'm going to use a property you guys have I've taught you guys in class. If A equals B, then what does B equal? Well, then B equals A. So basically I can just switch the sides of the equal sign and that's it. So this says 10 equals 5y minus 4x. I can also say that means 5y minus 4x equals 10. Same thing with the bottom one here. 4x plus 2y equals 0. These are still not in standard form. Almost, though. Only issue here is the top equation. And this is just going to be the commutative property of addition again. I want the x's to come first. The coefficient is negative 4, so it's a negative 4x. That's a positive 5y, so plus 5y equals 10. And this is all in standard form. I'm not going to touch that second equation. And here's what's really neat about this one, is my x's are already set up to eliminate. So let's see what happens when I do that. I've got opposite coefficients here, so those eliminate. 5y plus 2y is 7y. And 10 plus 0 is 10. Divide both sides by 7 to solve for y. Y equals 10 sevenths, or 1 3/7. I'm going to leave it as an improper fraction. You guys can write that as a decimal or a mixed number. And then we're going to substitute that back into an original equation to solve for x. Let's see here. This doesn't really matter. We'll go 0 equals 4x plus 2y. This is the second equation right here. But I know what y equals. Y equals 10 sevenths. So 0 equals 4x plus 2 times 10 sevenths. And we'll just solve from here. 0 equals 4x plus 2 times 10 sevenths is, I guess we could say 20 sevenths for now. We're going to subtract that off both sides because that's the constant, and we always get rid of the constant first. Gives me a negative 20 sevenths equals 4x. And then we would divide by 4 on both sides. And this kind of looks funky, so why don't we convert this number into a decimal really quick and see what that plays out as. So this is going to be x equals, let's see, 20 sevenths. And this might just be one for the calculator. Got my calculator here. Sorry, that took a second to get up. We're going to take a negative 20. We're going to hit the BC button here. 20 over 7. We hit enter. Gives us negative 2 and 6 sevenths. And then we wanted to take that number. Let's see here, negative 2 and 6 sevenths. And we still want to divide that by 4. And that's what's going to give us x here. Let me bring that back up. So we're going to take negative 2. I hit the unit button to get a mixed number, 6 sevenths. And we're going to divide all of that by 4. Negative 5 sevenths. Go. And then lastly, ordered pair, negative 5 sevenths, comma, 10 sevenths. And I'm perfectly fine with the fractions like this. You could type them in as a decimal, rounded to the nearest hundredth, or a mixed number, whatever floats your boat. All right. Now, this one says I can solve the system by elimination, any method. It doesn't matter if you use elimination or any method here. Y equals a negative x. 3x plus y equals negative 8. This is probably actually a good case for using substitution here. Okay, because I know what y equals. Y is alone, and so I can replace all the y's with negative x. Let me show you what I mean. In fact, why don't you pause the video and give it a shot. Ooh, that is an awful funky chicken bracket there. Let's try it again. There we go. Instead of using a system by elimination and getting this into standard form, by adding x to both sides, we could do that, but instead of doing elimination here, let's try substitution. Y equals negative x, so I'm going to use my second equation, 3x plus y equals negative 8, but I know what y equals. Y equals, here, a negative x. So I'm going to replace this y with negative x. 3x plus a negative x is it's the same thing as 3x minus an x. Is 2x equals a negative 8. Divide both sides by 2 gives me x equals a negative 4. We can substitute back into an original equation. I like y equals negative x. Remember, we're substituting, so we're going to take out the x and substitute it in with a negative 4. You guys might remember that two negatives, especially in multiplication, mean positive. So we have the ordered pair, negative 4, comma 4. And lastly, look at these large numbers. They shouldn't scare you all that much. Elimination is probably going to be our best bet here, so why don't we go ahead and get both of these into standard form and solve. Looks like my variables are both on the left-hand side. Looks like I just need to exchange these spots really quick, but I can't just turn them around like that. The minus sign doesn't stay in the middle. We need to make sure that we take this whole negative 3x and move it in front here. So it's going to be a negative 3x. This is a positive 5y. So plus 5y equals 30. And the other equation I did nothing with. Look at that nasty system. It's actually not that bad, especially if you got a calculator on you. All right, now you just need to ask yourself, what variables would you like to eliminate? I'm going to go ahead and try to get rid of these x's. So what I want is I want to turn this into a 9. It's already negative, and the way I turn a 3 into a 9 is by multiplying by 3. I'll write the system right below it. So I have, my first equation here, sorry, is 9x minus 15y equals a negative 105. And the equation I'm multiplying is going to give me, or times everything by 3, gives me a negative 9x plus 15y equals, let's see, 90? 90. Okay. Looks like 9x plus, sorry, we're adding, plus a negative 9x is eliminated. And also, negative 15y plus 15y eliminates. Now the question is, what's left? Well, 9x plus negative 9x is 0. We have another 0 here. And here we have negative 105 plus 90 is a negative 15. So basically what we're left with is 0 equals a negative 15. This is a false statement, but that is not the solution. Okay, this is not the solution. This is not what we submit as an answer. The answer to this is there is no solution. So remember that all false equations like this are no solutions. We know that these don't equal each other, so that's no solution. And just as a reminder, if we did get a true solution, like 2 equals 2 or 0 equals 0, that is a true statement, and that means there are infinite solutions, or that all real numbers work for x and y. So let's keep that in mind. That's going to be your review for today, guys. Go ahead and jump on to proficiency check number 10 and have at it. You guys have a good one.